So like I said, we will be solving systems of linear equations using matrices. So if you were given a system of linear equations, the first thing you would have to do is convert the system into a matrix. So we're going to talk about how you would do that. Okay, so on page 2, under augmented matrices from systems of equations, we read the first bullet point there. It says, we write a system of linear equations in matrix form by writing only the coefficients and constants that appear in the equations. The resulting matrix is called the augmented matrix of the system. Okay, so that's a new phrase there, augmented matrix. Okay, so here's how you do it. Okay, so say this were your system of linear equations. Okay, so you see this is something you saw back in 4.1. X and Y are your variables, and then remember A, B, H, C, D, K, those were just numbers. Fancy word for numbers is coefficients, okay? So basically to convert this into a matrix, you basically drop the variables, okay? So you won't see X or Y in the matrix. You're just gonna write down the numbers, okay? So if you were to take the first equation, okay, so look at ax plus by is equal to h, okay? Look at the matrix. First of all, you're going to see a vertical line here, okay? Think of that as the equal sign, okay? So on the left side of this vertical line, okay, think of this, okay, and I'm going to write it, well, I guess I'll write it down here. These numbers are going to be, the first column is going to be the numbers in front of x, and then the second column is going to be the numbers in front of y. But remember, you don't write x or y in the matrix, okay? So like the first equation, you have an a in front of x, you have a b in front of y, and then on the other side of the equal sign, you have h, okay? So that's how you would write down the first equation into the matrix, okay? Similar thing for the second equation. There is a c in front of x, there is a d in front of y, and then on the other side of the equal sign, there is a k, okay? So you want to make sure that you're putting all the numbers in front of x into the first column, all the numbers in front of y into the second column, and then your vertical line represents the equal sign, and then the numbers on the other side of the equal sign appear to the right of the vertical line, okay? So let's try this out in example 2. We are going to take a system of equations, okay, and we're going to write it as an augmented matrix, okay? So in part A, our system of equations is negative 8x plus 3y is equal to 10, and 6x plus 5y is equal to 13, okay? So I'm going to go ahead, draw a matrix. All right, so I'm just going to write down, basically you're writing down the numbers you see. So for this first equation, there's a negative 8 in front of x. There is a positive 3 in front of y. On the other side of the equal sign, there's a positive 10. Okay, so that's it for the first equation. Okay, and then for the second equation, there is a 6 in front of x, a positive 5 in front of y, 13 on the other side. Okay, that is it. Okay, so there you go. Let's try one more. All right, so part B, your system of equations is 5x minus y is equal to 10. And then the second equation is 3y is equal to 21. Okay, so again, let's write down the matrix. Okay, first equation, positive 5 in front of x, negative 1 in front of y, positive 10 on the other side of the equal sign. Okay, in the second equation, the x is missing. Okay, you have to put a 0 there as a placeholder, okay, or it's not going to work out correctly. If any variable is missing, you have to put 0 as a placeholder, okay? So think of it as 0 times x, and then the 3 is positive, so there's a positive 3 in front of y, 21 on the other side, okay? So that would be your augmented matrix for this system, okay? So basically, this is how this works, okay? You are going to be given a system of equations, okay? The first thing you're going to do is convert it to a matrix. And then you are going to operate on that matrix. And it's going to end up, the matrix is going to change, okay? There's going to be several different iterations of the matrix until you get to the final matrix, okay? Once you get to the final matrix, you have to interpret it, okay? So it's almost like you do the reverse. You take the final matrix and you turn it back into a system of equations to kind of interpret the answer, okay? So in example 3, we are going to do the reverse, okay? You are given an augmented matrix and you want to turn it back into a system of equations, okay? Because like I said, this would be a handy thing to do once you've operated on your augmented matrix and you get to the final one, and now you want to turn it back into the solution for the system of equations, okay? So in example 3, we are going to write the system of linear equations that is represented by the given augmented matrix. Assume that the variables are x and y. All right, so in A and B, you've got two augmented matrices. Okay, remember, no variables appear in the matrices, so that's why you're told in the directions you're converting this back to a system of equations. Okay, so you're going to use x and y. Okay, notice that for each one of these we have 2 rows. Okay, 2 rows, 2 rows. So every time you have a row, that's going to be turned into one equation. So this is going to represent 2 equations, 2 equations. Okay, all right, so remember, in this first matrix, the first column represents the numbers in front of x. The second column represents the numbers in front of y. Think of the vertical line as the equal sign. And then the numbers on the right of the vertical line are just the numbers on the right side of the equal sign. Okay. All right. So let's go ahead and translate this into a system of equations. Okay. 1, 4, 15, that first row. Okay. That means 1 times x plus 4 times y is equal to 15. Okay. So if I just kind of simplify that, I'm going to get x plus 4y is equal to 15. That's the first equation. Okay. Second row. Okay. 6, 0, 18. Translate that. 6 times x plus 0 times y is equal to 18. Okay. So if we simplify that, that's going to be 6x. 0y is going to be 0. You don't have to write that. So 6x is equal to 18. Okay. There's your system of equations. Okay. All right. Part B, we're doing the same thing, just taking the augmented matrix, turning it back into a system of equations. Okay. All right. So again, numbers in the first column are going to be the coefficients or the numbers in front of x. Second column, those are going to be numbers in front of y. Vertical line is the equal sign. Okay. 60 and 48 will be the numbers on the right side of the equal sign. Okay. We have 2 rows. Each row will produce an equation. So there's going to be 2 equations here. Okay. So let's look at 20, negative 15, and 60. Okay. That's going to turn into 20 times x plus a negative 15 times y is equal to 60. Okay. So if we kind of clean that up, this is going to be 20x minus 15y is equal to 60. Okay. And then the second equation, okay, negative 16, 12, and 48. The negative 16 is the number in front of x, so negative 16 times x, plus 12 is the number in front of y, so 12 times y. That's got to equal 48. Okay, so clean it up. We'll get negative 16x plus 12 times y is equal to 48. Okay, here's your system of equations that is represented by that augmented matrix. Okay, so again, in this whole process, you have to be able to go both directions. Okay, when you first start the problem, okay, and you first get your system of equations, okay, you're going to have to translate it into an augmented matrix. Okay, then we're going to operate on the matrix. Okay, basically the matrix is going to change many times. Okay, it will, all the different matrices you get will be equivalent to the original one. Okay, eventually you will reach a final matrix. Okay, and you will have to translate that final matrix, interpret it as the solution to the system, okay? And to do that, it could be helpful to take your final matrix and turn it back into a system of equations, okay? In example 3, when we turned it back into a system of equations, these two are really hard, to interpret a solution of, okay? This was just to get you into the idea of taking an augmented matrix and translating it back into a system of equations, okay? All right, so now what we're going to do is talk about, once you have your augmented matrix, your initial augmented matrix, okay, you go from the system, the original system, to the first augmented matrix, we're going to talk about the operations you can perform on your augmented matrix, okay? So here we go.